Okay, it's simply a grooved wheel which has got either a piece of rope, a chain, or a cable over it, which then has a load attached on the one side with something or someone pulling on the other side. That's pretty much the basic definition of a pulley. Okay, simple enough? Must I go slower?
So can you write it down, sir?
Okay, no, I'm not writing it down. You can write it down. I said you write it down. Okay, it's a grooved wheel which has got either a cable, rope, or chain over it with a load attached to the one side and somebody pulling or something pulling on the other end. You got that? Okay, then you're going to get it from somebody who's videoing. Okay, that's our basic definition of a pulley. Now, there's 3 different types of pulleys that we're going to go over. Okay, 3 different types. And we're going to learn and check up on what kind of mechanical advantage each of them provides us. And we're going to see in what kind of ways they help us in everyday life, etc. But first of all, I have a video that I want to show you quickly. You can video the video. Totally fine to video the video. I need somebody to turn off my lights, please. And I think you might need to close that light.
Should we stop this video?
No, don't stop your video. You're just going to video the video.
So when you speak, can you stand up?
Yeah, I will try and stand. Okay, let's just wait for that to come up. This is quite a little humorous little sketch video. Explaining the basics of pulleys to you, and once it's done, and I'll pause it once or twice in between, but once it's done, we'll then go and chat about our 3 different types of pulleys. Okay, here it comes. Here it comes to save the day. Okay, what you do now is put the sound in, and put the sound on. Yay. Okay, I need you paying attention, please. Thank you. Yeah.
The pulley. The pail of water that Jack and Jill had to fetch was not on top of the hill at all. It was actually at the bottom of a well. Unfortunately, it was too heavy for either of them to pull up. What they needed was a simple machine to give them a mechanical advantage. No, the inclined plane doesn't help. Nor does the lever. Nor the screw. What other sorts of machine are there? Ah, yes, the wheel. But what's Jill doing with it? She's arranging the wheel so that it will revolve on an axle stuck in that post. Very good. Jill's just rediscovered another sort of simple machine. A wheel that, instead of being all of a piece with its axle, can revolve freely around an axle. Since this type of wheel is used mainly for pulling things, it's called a pulley. And Jill can hitch the rope around it and use it to pull. No, Jack can use it to try to pull the pail of water up. That's funny. He needs just as much force to try to pull the pail of water up this way as he did trying to pull it up the other way. I wonder if there's a better way of rigging the pulley. Amazing. How did Jill manage it? Both she and Jack only had one pulley to work with, and yet Jill was able to pull up the pail with half the force that Jack needed. Well, when a pulley is set up like this, it's called a single fixed pulley. All it does is change the direction of your pull. But
okay, that's the first type of pulley that we're going to look at. Okay, just now, single fixed pulley. I don't have to write it down yet. I'll give you time just now.
It doesn't reduce the force you need. But when a pulley is arranged like this, it's called a single movable pulley.
Second one.
And it halves the force you must exert, because the pail of water is now, in effect, being lifted by 2 ropes instead of 1. It's as if 2 people were lifting the pail. And it looks as if we're getting something for nothing again, doesn't it? But of course we're not. If we compare the distance that Jill raised the pail with the amount of rope she pulled, we see that it's the same old story. What she's gaining on the force, she's losing on the distance. The distance that she pulls the rope is twice the distance that she raises the pail. But the way Jill used the pulley is still twice as effective as the way Jack used it. There are lots of other ways of combining pulleys. The pulley system that Jill finally rigged up for herself. She had to pull the rope 3 meters for every meter that she raised the pail of water. In a sense, she'd become 3 times as strong as Jack. And now you know why Jack fell down and broke his crown.
Okay. That's the little video I wanted to show you. Okay, so from that little video we've got our first 2 different types of pulleys that we're going to have a look at. The first one, as they stated there, is simply a single fixed pulley. That is the most simple, it's the most simple version of a pulley that you can get. Okay, which is simply a pulley's wheel, okay, with a little axle on that end, and then a rope or a cable or a chain over it with a weight on the other end and with somebody pulling on that end. Somebody pulling on that end. Okay, now this pulley is attached. Let's draw a little funky tree branch over here. Oops, that's very bad tree branch. Okay, very funky looking tree. And that pulley is attached to the chain there onto the tree. Okay, and the reason why it's called the single fixed pulley is because that pulley over there can't move, it's fixed. Okay, it stays in one place. And then your rope is over that pulley and you pull from this side to lift up the weight on that side. A pulley's got a groove in it. If you had to take this pulley and turn it like this and look at it from the side, you would see something that pretty much can look like that. Okay, you would see a picture that looked a little bit like that. Okay, that's what a pulley looks like from the side. There's a groove in the middle here, and your rope sits there in the groove. Why did they put a groove in it? Simply because it makes sure that the rope doesn't slip off to the left or the right. That little video that you just watched, that wheel that they had was just simply a wheel, and the rope could have slipped off nice and easily, but that makes sure that your rope doesn't go anywhere. Rope or cable or chain or whatever you might be using. So that's what it looks like from the front. From the side, however, it looks like that. Now, they said in that little video, and if you have a look in your textbook says that that your mechanical advantage here is equal to 0. Simply saying that if you've got a 20 kilogram weight on this end, which produces how much force? 200 newtons. Yeah, you should know that by now. We did it with hydraulics. Okay, it produces a force of 200 newtons. We would need a force of 200 newtons to pick it up on this end. Hence, no mechanical advantage. The book's actually wrong. It's not a mechanical advantage of 0, it's a mechanical advantage of 1. Okay, because the amount of work that you do on this side is the amount of work that comes out on that side. Okay, then the other thing that the book is wrong about is the fact that this gives you no mechanical advantage. What would the point be of a single fixed pulley if it gave us no mechanical advantage? Because what we said at the beginning of this section is that we are talking about machines, simple mechanisms that give us mechanical advantage, that make life easier for us. Now, if this doesn't make life any easier, what's the point? So there must be some form of mechanical advantage here. You can't write down in value form. Okay, there's no value for it, but there is mechanical advantage in that system. Can anybody tell me what it is? It was actually mentioned in that little video. Yes.
It's because, like, if you had to pick it up normally, it's easier to lift like this because, like, it's raised.
No, not quite. I think your brain's trying to go in the right direction, but not quite. Anybody else? Give a suggestion? No? Okay. Very, very simple. Okay. You instead, if you had to take that 20 kg weight and you had to attach a rope to it and you had to pull it up like that, pulling it up like that is way more difficult than pulling down on a rope. Because if you pull down on a rope, you can put all of your weight behind your pull. Whereas if you're pulling up like this, it's only your muscles, and you'll only be able to pull up you'll only be able to produce as much force going upwards as what your muscles can produce. Whereas pushing down, it's your muscles and your weight that you're able to use. So there is mechanical advantage in that setup. And that mechanical advantage is that it changes the direction of the force being used. That is your mechanical advantage there. It changes the direction of the force that is used to pick up the load. Because it's way easier to pull down than to have to pick it up. So that system actually does have mechanical advantage. Okay, but you'd have to write it out in words instead of giving a number to it. Okay, yes?
So when you say fixed, you mean that little, the circle won't move at all?
No, that pulley doesn't move at all. Stay still. Okay, so that's our first one. That's our single fixed pulley. The next one that was on that little video was a single movable pulley. Okay, single movable pulley. Now, with a single movable pulley, all they've pretty much done is this. They've now taken the weight. Sorry, let me just get this out of the way, because that's 908. They've taken the weight, and let's say my branch goes a little bit longer here. They put a hook on the end of that branch there. Okay. They've tied the rope to that hook. Okay, over there. Tied the rope to the hook. And then they've taken the rope and they've made it go down and up, and they've put a pulley over here. Now you'll see that in that little video there wasn't a pulley here, and in your textbook there isn't a pulley here. They call it a single movable pulley. In real life, you would never ever, well, I won't say never, you will rarely see a setup where you simply have that. Simply again because it is more difficult to lift up than what it is to pull down. Your setup would normally have two pulleys in it, with one movable pulley and one fixed pulley. Now, the reason for the movable pulley is because now what happens is if you've got your weight attached there, my 20 kilograms, which still produces 200 newtons. As you pull down on the rope, that now lifts the pulley and the weight at the same time. Now, you would say, now what's the point of that? What mechanical advantage does this system give us? Okay? On that little video, it said that that Joel was able to pull up the pail of water with half the amount of effort when she had that set up on the pail of water. Correct? That's what they said. So that simply means that if I have that set up, now instead of having to use 200 newtons of force to lift up my pail, I only need to use 100 newtons of force. Now, why is that? Why? So what? Why? Yes? No? Thinking about it?
So the only thing I can think of is because that's pulling the weight is pulling the pulley down, and then that pulley is still in the same position. So when you're pulling it, it's easier for that one to move higher up and bring that with than if it was just...
Nice try, not quite. Okay. You want to try?
No.
No? Not going to try? Okay. Now, very, very simple. If you take a very heavy bucket, you guys know those big chlorine drums that they have down by the pool?
Yeah.
Okay? Those are pretty big drums. If you had to fill one of those with water, one person ain't going to be able to pick that up at all. But if you had to fill it with water and you had to have two people, one person standing, picture this. Well, let me not picture this, let me draw it. There's my big thing filled with water to the top. Okay? Handle over there. I got one person here. And another person here. Okay? Let's say that instead of the one person trying to pick it up, they both put a hand to it, and they both pick it up together. Now, what's happened? Let's say that this was 50 kilograms, 500 newtons. If one person was picking it up, to pick up that pail, that thing of water, they'd have to produce how much force? 500 newtons. But now if you've got two people picking it up, how much force does he have to produce?
250.
250, and him?
250.
250. Because the force is now shared between the two people. So that guy's arm has to produce 250, and that guy's arm has to produce 250. The weight is shared between the two arms, between the two people. Now exactly the same thing is happening here. Because you've got a movable pulley over here and one fixed over there, this piece of rope is holding half the weight, and this piece of rope is holding the other half of the weight. Okay? That weight is being held up by two pieces of rope here instead of just one. Can you see that? Okay? That piece of rope is holding it up, as is this piece of rope. Okay, so there's a certain amount of tension here and a certain amount of tension over there. So 100 newtons of weight is held up there, and 100 newtons of weight is held up over there. That's why we only need 100 newtons of weight on this side to be able to put it up. The force has been split in two, which causes our mechanical advantage. So there's a little name for this. Each of those pieces of rope is called a fall. So in this case we have what we call two falls, okay, or two pieces of rope which are holding up the weight, and because of that, that then gives us a mechanical advantage of 2. Okay, for the amount of work that is done on this side, that mechanism allows us to do double the amount of work in the system. Happy with that? Now, let's see what happens if you add in another pulley. Let's say that we had to take our little man out, and let's add in another fixed pulley. Let's put another little fixed pulley on our tree. Another little chain. Okay, we fix our pulley over there. And we make our rope. Hold on a minute. Is that going to work? No, we need another movable pulley in too. Okay, let's put another movable pulley over there. And our rope is now going to go like that. Come around, go over that one. Okay, come up there, there's a little man. And there's putting on your rope. Okay, now with that system, let's see how this one works now. Okay, now you've still got your 200 newtons on the bottom there, and the dude pulling on the rope over here. But now, how many ropes are supporting that 20 kgs of weight?
5.
4. 4. That one there, that one there, that one there, that one there. So now if 4 ropes are supporting it, how many newtons go into each rope?
50.
50. 50 there, 50 there, 50 there, and 50 there. So now how many newtons of force do you need to be able to pull it up?
50.
Only 50. What's our mechanical advantage? 4. Because we can do 4 times the amount of work by having our pulley set up like that. How many pulleys are in that system? 4 pulleys. Doesn't that equal the amount of mechanical advantage you get? How many pulleys were in the last system?
2.
How much was our mechanical advantage?
2.
So you can safely say that the amount of pulleys you have in the system will equal your mechanical advantage. Okay, yes.
So what would the second movable pulley be attached to if it's movable? Wouldn't it be a fixed pulley attached to like the ground or something?
Yeah, that one would have to be fixed.
Yeah.
Yeah, that one would have to be fixed to something else down here somewhere. Because otherwise it won't work.
Yeah.
Because otherwise you just have this one moving up to there and then pulled straight out.
Yeah.
Yeah, that one would have to be fixed with that one movable. Quite right. 3 fixed pulleys with 1 movable one. Okay, everybody happy with that?
Yes, sir.
Okay, quite straightforward. So now you know we've gone over 2 different types, a single fixed one, which has no mechanical advantage numerically, but we know that it has the mechanical advantage of changing the direction of the force. And the second one, a movable pulley, has a mechanical advantage of 2, because you've got 2 pulleys and 2 pieces of rope that are now holding up your weight instead of just 1. And if you add in another 2 pulleys, your mechanical advantage becomes 4. If you had 3 pulleys, you'd have a mechanical advantage of 3, etc., etc., etc. Okay, and I think our time is up. Okay, so